Hey there, and welcome to The Explainer. So today, we're going to decode this system that makes sure your degree, especially if you're in something like CAD modeling and analysis, actually has real-world value and gets you recognized around the globe. Okay, so let's just dive right in. Have you ever really thought about what makes your degree so valuable? It's not just about the classes you take, right? It's all about this really smart framework that's designed to guarantee the quality of your education, and maybe more importantly, its relevance to the real world. So where does this all begin? Well, it starts with a word you've probably heard before, accreditation. Think of it like a powerful seal of approval for your degree, making sure it's respected not just here at home, but anywhere you might want to go. And this law, it's basically the bedrock of the whole system. It makes sure that anyone who wants to be officially called an engineering technologist has to meet a really high academic standard. And that's step one, right? The first piece of the puzzle, to prove you know your stuff. Okay, so that's the national level. But here's the big question. How does a local standard actually get you an opportunity on the other side of the world? How does a degree from one country get understood and valued in a completely different one? And boom, here's the answer. Agreements like the Sydney Accord. It's literally a global passport for your degree. Because Malaysia is a full signatory, it means your qualification is seen as top-notch in places like the US, the UK, Australia, the whole shebang. All right, so that's the how. Now let's get into the what. What's the philosophy that makes this whole thing tick? It's something called outcome-based education, or OBE for short, and it really changes the way we think about learning. I love this quote. It's not what we teach, it's what you learn. I mean, think about that for a second. This one idea completely flips the script on education. The focus shifts away from what the professor is saying and puts it squarely on you, the student, and what you can actually do with the knowledge. You know, the old way was just professors listing topics you had to memorize for a test. OBE is totally different. It's all about defining what you, the student, will actually be able to do once you've learned the material. It's about proving you have real, usable skills, not just that you can pass an exam. Okay, so how does this actually work in practice? Well, it's all built on this really cool three-level blueprint. You'll hear these acronyms a lot: POs, POs, and LOs. Let's break them down. Think about it like you're building a house. The LOs, those are the individual bricks, the 2x4s you learn in every single class. Then you have the POs, which are like the fully finished rooms. That's your complete skill set when you graduate. And the POs, well, that's the whole house, standing proud in the neighborhood. That's you, a successful professional a few years into your career. So let's start at the top. PEOs are the big picture goals. They're all about who you're going to be 3 to 5 years after you graduate. You know, someone who's actually using their knowledge, who keeps learning new things, and can handle whatever new tech comes their way. Next up, we have the POs. And I love this description. They are your tangible toolbox of skills that you have the very second you get that diploma. These are the things you can literally list on your resume, ready to go from day one. And what's so important to see here is that this isn't just about the technical stuff. The system is designed to make sure you're also great at solving tough problems, that you understand professional ethics, you know how to work in a team, and maybe most importantly, that you get why it's so critical to never stop learning. And finally, we get down to the level that you see every single day, the learning outcomes, or LOs. These are the specific, concrete skills listed right there on your syllabus for every class, including your CAD modeling and analysis course, for example. Okay, so now we have all the pieces, POs, and LOs. Let's connect the dots. How does one little assignment in one class connect all the way up to those huge career goals? And this is the key takeaway right here. Nothing in your course is random. Every single test, every lab, every project, it's all there for a reason. It's a carefully placed building block designed to prove you're mastering a very specific skill. And check this out. This is the blueprint in action right here. Look at the table on the left. You see how each assessment, a test, a lab, is tied to a specific learning outcome, like LO1 or LO2? Okay, now follow that mapping over to the list on the right. You can see exactly how mastering those specific skills in your class helps you build those bigger, broader career skills, like PO1 and PO3. It's not a secret. It's right there in black and white. So what does this all add up to? It means that every single thing you do in your program is purposefully building a set of skills that companies around the world are looking for. Your grade isn't just a letter or a number anymore. It's direct evidence. It's proof that you can do what your degree says you can do. So, next time you see LO1 on a syllabus, what's it going to mean to you? It's not just some random code, right? It's a signpost on your career map. It's a promise that what you're doing right now, in this moment, is a crucial, deliberate step towards becoming the professional you want to be.